There it is.
There it is.
Okay,
Hey, everybody.
action.
Good morning. On a Monday morning when we're recording this, could be any hour of the day. It's Baron Ron Heron, about to proudly host our weekly podcast on Zoom, live from our man caves and computer dens of the Santa Barbara Astronomical Unit, South Coast Longtime Astronomy and Telescope Club, keeping our organization alive during the pandemic by meeting once a week on Monday mornings, all being archived. In fact, you can see them on YouTube live. Tell your friends it's the SBAU Astro Hour. And would you believe we've done 37? This is number 38 for the year 2021, November 15th through the 21st. Got a big week ahead. Let me tell you some of the headlines, stuff we'll probably be talking about. There's going to be a near total eclipse of the moon, our moon, this week. And we have Exo Moons being discovered on distant exoplanets. Can you believe that? It's also a dwarf planet, number 1 Ceres. It's a large rock out in the asteroid belt we may get to. And happy 283rd birthday to the discoverer of Uranus. That would be Frederick William Herschel, I assume a German astronomer. Man, that's a forest fire on his birthday cake there with those demon star. We'll talk about that maybe. Let me introduce the gang. Without Chuck today, Chuck is off doing. Anybody know what Chuck's doing? We'll find out.
Nope.
Outreach coordinator is on assignment. We'll say Jerry Wilson's the president. Good morning, Jerry.
Good morning.
How's your lovely wife Pat Forgy doing? Very active.
Good.
All right. Third season, I guess, going into the fourth as president. And we have Tom Whittemore in the middle of my screen. Tom, good morning.
Morning, everybody.
Former Westmont College science instructor, editor of our incredible newsletter. Running the show is Tom Totten, webmaster, technical wizard. Tom, you do a great job. I love it. Thank you. He was former president as well. And then Bruce Murdoch is on board, longtime active member, president of the Santa Barbara Theater Organ Society. I got to tell you, if we had time, I'd ask about the Organ Society and then go over to Whittemore and ask about the bird watchers, but we don't have time. We got a lot of stuff to talk about. Can I run down some news items before we do a few of Jerry's cartoons? We mourning the loss of our beloved hardworking secretary, Carol Ann Moore, for health reasons, is stepping down. Haven't seen her anyway. Chuck McPartland, who is not with us today, our outreach guy, he's awesome. He did attend a special space event a week ago last Thursday night. It might have been a Veterans Day benefit, I'm not sure, but he was out there at the old, what's the name of the hotel along the freeway? Anyway,
Miramar.
It used to be the Miramar. It's Rosewood Miramar now, I guess.
Yeah.
He told us in an email he ran into a Vandenberg meteorologist who's one of the safety deciders for the launch of that DART mission from Vandenberg Space Force Base. Has that happened yet, or is that happening this week?
This week.
It'll be this week. And he might want to join the club. We don't have his name yet, but we're working on it. And he'd probably make a great speaker, too. Jerry intercepted an email from a young UCSB student with an interest in astronomy, possibly joining us. And if the Santa Barbara Museum of Natural History allows us to open for our second Saturday night of the month star parties, you're all going to be welcome, but you'll have to, I guess, wear masks, and we all have to submit our vaccination reports to the museum. November newsletter is out. It's on screen. Why don't we take it local moon and then go distant moons, gentlemen, because this is fascinating stuff. A near total eclipse of our moon is this week, a lunar. Thursday night late?
Thursday. That's right, Thursday.
Tom, you want to tell us about it? What do you know?
Who, me?
Stage is set.
You're the only Tom on.
Well, there's Tom Totten.
That's right.
Yeah.
Well, over 99% of our moon will be illuminated. The stage is set. It'll be late at night, and I guess it'll cross the USA, right?
Yes.
Northern Hemisphere.
Jerry, correct me if I'm wrong. Isn't it about 11 o'clock in the evening on Thursday?
Yes.
Yeah, okay.
The maximum is around 1 a.m. Pacific Standard Time.
Okay. And of course, to have one of these, you need to have a full moon. And so there is a full moon towards the end of the week. These full moons are really interesting because they are rising, of course, opposite the sun. The sun is setting in the southwest, so the full moon's rising in the northeast. So folks will want to look for up in the sky in the northeast, okay, for that eclipse. And thank you, Tom. That's beautiful.
Nice.
You can see why they call it almost total, because there's just a little wisp, okay, that Tom's just noted there, okay, that has, some shine on it. Should be pretty nice, should be beautiful. It's worth staying up for. Lately, the skies have been very, very clear, so maybe we'll get a good wink at it.
I'm curious, what does a lunar eclipse look like during the day? How does that
Can't
change?
happen during the day.
Right.
Well, see, at universal time, at Greenwich, I guess it's 9 o'clock. Oh, that is evening, isn't it? Yeah.
That's to be on the other side.
Yeah, that's right. I'm looking at 11:05 a.m. over here, where it starts.
Tom,
Is that
you
right?
pulled the Baron. You pulled the Baron on that one.
Let's see. It's 11:05 a.m. Is that the start of what? Oh,
PM.
deep.
Is
Oh,
it
you'd be hard pressed to
That's
see.
1 a.m. Eastern Standard Time, which is 10 p.m. Pacific Standard Time here.
Yeah, they're 9 hours up, right, Jerry?
The Eastern is
In England.
from England. I think we're 8 hours
It's
different
8.
from England.
Okay.
The this moon during this eclipse will be handily high in the sky,
Yes.
so it should be very easy for everybody to see.
Right. This moon is probably, yes,
All
if I'm guessing right, this moon is probably going to be in Leo, which will take it high in the sky.
yeah.
but it's
Calls it a
another-
beaver moon. What's a beaver moon?
A beaver moon? Is that what you said?
I just opened I got the same graphic that Tom has.
Uh-huh.
The title
Yeah.
is the Beaver, Beaver moon eclipse on November 19th will be the longest of the century.
Okay. It's probably
Yeah.
Native American term, be my guess.
Old names applied to the months in order to give rural farmers, a time sense of when to do certain things, to harvest, to plant, to go hunt beavers for new caps, whatever. They're ancient names. I mean, there's not one clear name for each month moon. Each month moon will have probably several names depending on the region you get the information from.
Interesting.
Can you?
Another thing to notice here is it reminds me, going back to my first teaching at Ohlone College many years ago, back 1997. It just turned out the first night I was teaching the astronomy kids was a lunar eclipse. And so I asked the kids, I gave them how far away the moon was from the Earth, how far the Earth was away from the sun, what kind of extent they had. And I asked them to calculate how big the shadow of the Earth would be, okay, at the full moon position. And you can see on the picture, it's about three diameters, just roughly, at the location of the moon. So the shadow of the Earth is quite broad. It's very broad. Okay, and you get a sense of that too during these eclipses. You get a sense of the ball of the moon too, which is always pretty neat. But you see how big that circle is there, you guys?
Yep.
So it's roughly 3 times the moon diameter, just roughly. And the kids got it right. It was fun.
You lost me on that, Tom. What's roughly 3 times the diameter?
Oh, the shadow. So the extent of the shadow at the location of the moon that the Earth casts there. Okay. You see how
It's labeled umbra.
Umbra or penumbra? Which, let's see.
No, penumbra is the one that's partial. Umbra is the total part.
Yeah, it's the umbral shadow that's asked for the students to calculate.
Can you make it so I can share a screen?
Sure, I'll stop share here.
Okay.
Go ahead.
Can you see this?
Not yet.
We see you.
Okay.
Yeah. It should come up with a window that says share multiple different windows.
Oh, I see. Okay.
And you got to click on the one you want to share.
Yeah.
You're a little tiny. Yeah. Got to make a guess. Which one's what?
Okay. You can see over here the names, common names of the full moons each
Okay.
month. And you see November down here is the Hunter's Moon, the Frosty Moon, or the Beaver Moon.
Okay.
And this is the
Okay.
Beaver. Okay. No Harvest Moon in there. That was October.
Yeah, harvest is, yeah.
Mhm.
Okay. Wow. The first time I ever heard of a Beaver Moon. Any reason for you guys to get up with your telescopes Thursday night?
Oh, for me, I think it's just a lot of fun just to look at it with your eyes.
Okay, you have it back, Tom.
Binoculars help sometimes. Okay.
Well, look, I guess middle of the night, I'm not sure. Would it be impossible to have it earlier or the next morning? It has to be. Is there a reason? Because what Tom brought up a while ago, obviously you can't see a lunar eclipse during the daytime, right? Because the shadow
Right.
goes the other direction. But
The shadow only is behind the Earth, so you can only see it from the night side, and the moon can only be there when it's full, opposite the sun.
That's right. Mhm.
but could it be any time of night, or is it around midnight like it is in this case?
No, they can start
Oh.
at different times.
Yeah,
Really?
I mean, I've seen, eclipse moons rise, at sundown.
Yeah.
You know,
So that reminds me of a joke from a recent science fiction story where people were at a bar talking about what the important things in life and philosophy were, the important questions that they wanted to take over or try to answer as their advanced doctoral thesis. And one of the guys came up with, he said, I wanted to study why the sun doesn't come out at night when it would be more useful.
yeah.
Well, before
Or
we
if
go,
you send a probe, if you send a probe to the sun, do it during the night.
yeah, exactly, a lot better. We're going to be talking about moons in distant solar systems beyond ours, exo moons. But since you brought up a joke, Mr. Totten, how fast can you go to the one called Low Gravity of the 5 cartoons that were emailed to us, forwarded by President Jerry?
Yeah, I can get there.
This
Give-
is an
give me a
astronaut sitting up on the
20
moon
seconds.
during the eclipse. You can get to it while I set it up. Discovers a downside of getting breakfast toast on the moon.
Oh, yeah, right.
Oh, crap, I said. That's in orbit.
And the toast reached escape velocity.
Yeah.
Yeah.
Yeah,
So-
gravity on the moon is only 1/6 that
Yeah.
on the Earth.
Now, if you can call up the other one, we'll do one more. Out in space, the one called Uh-oh. That's what Jerry highlighted as Uh-oh. Look carefully at this one when we get to it, folks. From a distance, 2 astronauts are sitting in their capsule looking back at the Earth, and they see something about our planet from a distance that's rather disturbing, never seen before. One of the
Balloon.
spacemen says to the other, listen, I think we better keep this quiet.
Yeah.
Earth is
Notice
tethered
that.
with dangling
Notice
cord.
who did it? Of course, the great Gary Larson.
Yeah.
Was it a Larson?
Yeah, it's Gary Larson, and also it's back in 1980.
Well,
So
then,
it's over 40 years ago.
then President Jerry's
Wow.
digging into his own archives.
Let's go to half black, half white, half black. Talking about moons.
Okay, that would be the moon around Saturn,
Yeah,
two-faced.
Iapetus.
Okay, half white and half black. How is that? Why is that? Reaching inferior conjunction. I hate to call anything inferior. I really
Yeah,
do. This
maybe
day-
it
He's
was-
inside.
Okay, well, it's reaching that conjunction today, appearing closer to the ring planet than usual. After dark, look toward Capricorn, see the magnitude 11 moon. Which one is it out from the ring planet? Is it the closest?
Well, I don't remember the rank.
Okay, well,
It's
it's,
the picture that Tom is showing right now shows the fact that it's about half white and half black. And cutting right to the chase, the simple answer is that the moon is actually made of pretty much all of ice. That's the white stuff. And the black stuff is it's picking up a trail emitted by another moon, Phoebe. And it's as it runs into it, it picks up, it gets darkened by the debris and dust and stuff that's thrown off by Phoebe. Now, the only reason that it stays bifurcated like this, part white and part black, is that it's a chronosynchronous moon. That means it always presents the same side to Saturn, and therefore always presents the same side to the forward part of the orbit. So it's running into whatever Phoebe is throwing off. If it were rotating, then it would be uniformly covered with the black stuff. But since it's not, it's always presenting the same face.
Well, that's called tidally locked.
It's tidally locked, yes.
Okay.
And I also have a picture of Phoebe down here. You scroll down, it's a much smaller moon, and I think was the first telescopically discovered moon.
Okay.
It's heavily cratered. No, not the Earth.
Oh yeah, I got it.
Okay.
Hang on there. Sure.
Phoebe, huh?
Yeah. Okay, there it is. Now I don't see any volcanoes or anything, so it must just be just, throwing things off because of all the collisions. It looks like it's been battered around quite a bit.
Mm-hmm.
Phoebe is supposed to be a moon that was a core of a differentiated larger body, but it's been hit so much and so often that it's twisted out of its spherical shape.
Really?
So that's probably where all the debris came from that is on Iapetus.
So it's not asteroid size. It's not small.
Well, no, it's asteroids can be this large.
Okay, but there's one of the two around Mars has got a name similar. Phobos?
Phobos, yeah, fair.
Yeah, Phobos.
Yeah, but they're small. They're like what, 10 miles?
Yeah.
Well, that's what I was thinking. Doesn't it? If it's big enough, it becomes a total sphere, doesn't it? A sphere?
It does, unless it's pounded. That the blacksmith pounded it out of shape. This was 132 miles in diameter.
Oh.
So, but it was discovered by telescope by William Henry Pickering in 1899.
Wow.
Wow, interesting.
Yeah.
And,
yeah, go ahead.
And that's the one that affects Iapetus?
Yeah, apparently it gets hit and it throws debris off, which populates its orbit. And then Iapetus runs into it. They're not in the same orbit. The debris field spread out.
But these
I didn't realize how far Phoebe was from Saturn. It shows here Titan is this orbit here, and Phoebe is way out here. Wow.
Mm-hmm.
Okay, so they're not shepherd moons.
No.
Trump is captured.
Okay, Iapetus is
It could be an asteroid, yeah.
the fact that one side, the white side, faces the planet has nothing to do with the planet itself. It doesn't somehow reflect on it or shine on it somehow.
I don't understand the question.
Well, isn't the white side the side that's lit up, that's tidally locked and facing Saturn?
The whole moon is tidally locked, and probably a side of the moon that's half black and half white face the planet, because you'd have to be trailing Iapetus in order to see it as all white, and you'd have to be ahead of Iapetus to see it all black. And you can't be on Saturn for any of those positions.
Oh, it's half and half.
Yeah.
And we're not looking at a phenomenon similar to what we saw on Pluto, that big heart-shaped light.
Thing. No, there's no one throwing off crap to get one side of Pluto. But all these objects run into crap. It's just that this one always runs into things with the same side forward.
It's kind of a technical scientific term, Jerry.
Yeah.
Interesting, Iapetus.
It's technical crap. Okay, now let's go to the exoplanet moon.
Yeah, of all things, man, all those years not being able to even know if there were planets around distant stars. Now we're finding moons, or at least moon places. They're made circumplanetary disk.
What we just looked at was all invisible light taken by telescopes and spacecraft and Hubble maybe. But this one, the Exo Moon is in the formation stage, and these images are captured by radio telescope in the Atacama Desert. And this is a still from it. Tom, can you show the video that's the URL is listed there?
Oh, really? Let me see. If not sure if I saw that.
Are
Gotta
we
look
allowed?
look down the page here.
Are we allowed to do that?
Oh, sure. Let's see. We'll see if we can find it.
It's a
Part of
YouTube
the-
video.
We're part of the
There's a
YouTube
video
family now.
somewhere, huh? Let's see. Oh, right there. Okay. Okay. Very good.
How long is it?
Oh, not long, minute.
It's
Oh.
a minute long.
Okay.
Jerry, how far away is the mother star for this thing?
From the planet that's forming.
Yeah. Mhm. Oh, no, from us. How far away the mother star is from us?
Oh, I think it's 3. Let's see, where is it?
300 light years or something like that, right?
Yeah, something like that.
Wow, it's pretty impressive.
370 light years from Earth.
Okay, okay.
Here we go.
Oh, this, yeah. PDS 70.
Can you see the video okay?
It seems to be jumping instead of smooth motion. But that's okay, it'll work.
Wow.
Are we missing dialogue or music?
The blob at about 2 o'clock there was the forming moon. This is the central planet, which is like a Jupiter-like star. That's not an actual image of it. And that's the formation disk. And you can see as soon as we get out there, you'll see the, there.
Is that the Goldilocks zone or?
No, that's not a Goldilocks zone. That's just a ring of crap and dust that's forming. You know, when the solar system starts, it starts from a big turning disk. I hear an echo of my own voice.
Mhm.
And inside of this big disk, there's little turbulent, other smaller circulating zones, and those condense into planets. And in those planetary disks, there are even smaller disks that can form into big moons or double planets.
Double planets?
Because they came from the same disk, but
They
are,
orbit each other.
yeah, they orbit each other. Just to think of a big moon. I'm not sure if that's stable over the long term. Say you had 2 equally massive objects circling each other and also rotating around the star.
And the planet is a big gas giant like Jupiter or Saturn.
Yeah,
Okay. So we're watching what happened to our solar system
yeah.
ages ago.
Tom is pointing out with the cursor, he's pointing out the moon that's forming around it. So that's another knot in the planetary disk. And this is in the solar disk. The sun is off to the left.
But they wouldn't be able to spot with a telescope an actual moon that's complete and orbiting a planet.
This resolution is well beyond telescope resolution for visible light, but the Atacama Desert or whatever the ALMA
Telescope.
radio telescope array has a much higher resolution because it has.
Oh, it's got a very large aperture.
Right, bingo.
And so that accretion disk or whatever circumplanetary is huge and big enough to get picked up by the radio telescope. A moon itself wouldn't probably.
Yeah, the moon is right there. Thomas, the arrow is pointing at the moon.
There's one moon in the middle of the disk.
Not in the middle of the disk, but just offside. In the middle of the disk is the large Jupiter-like planet there. And the other one is the moon that's forming around it.
So they're all collecting material from that proto disk or that big disk of stuff.
Yes, it's in the process of formation.
Right.
So is this the old primordial gas and dust cloud type thing?
Yes.
What has always interested me about gas and dust, gas came with the original Big Bang, did it not? We had hydrogen gas. Dust had to come from stars that blew up. They're solids, aren't they?
Yes, you're thinking of dust grains like in your living room floor.
Yeah, right.
Yeah, but those had to be created later.
Exactly.
The hydrogen forms molecules when it gets cool enough. There was some helium made and extremely small amounts of other heavier trace elements probably, but not enough to populate the universe with any sizable amount of dust. The dust part came from generation 1 stars. Generation 2 stars, I know it sounds chronologically wrong, but generation 2 stars are the first stars. And then generation 1 stars are the ones that came after it.
Right. Even helium would indicate it had to come from a blown up star, right?
Not so necessarily. There was a lot of helium made at the beginning, but
Oh, there
not
was.
much compared to hydrogen. But the rest of the stuff formed in stars, but stars formed right away. So it didn't have to wait long. After 1 billion years or so, there was plenty of dust around.
Do you suppose all the elements, or at least the ones that we have on Earth, I guess we got them all here, are in that circumplanetary disk, or in it, with all that stuff?
Possibly. It's
In other
not
words,
impossible.
okay. But if it's a Jupiter-like gas planet, it's going to have many, many moons made out of that disk stuff.
Maybe. Maybe it's just starting with one and then it's going to steal the rest from other planets. You don't know what these guys are thinking.
We do have a name, PDS-70C.
Yeah.
In case anybody asks at a cocktail party and you want to know something.
Mhm. Now
Exo
the super big ring around there, that may be something that corresponds roughly to our Kuiper belt.
Oh, that big.
Yeah.
Well, our sun to Earth distance, which is in our name, AU, is somewhere in there. What? The disk itself is 93 million miles across, or radius?
Yeah, that's right there. That's about 1 AU across, or it's bigger than 1 AU across.
So whatever that star is, it's Jupiter would be where we are in this solar system of ours.
No, that's 1 AU between Jupiter, the Jupiter planet, and its moon.
Oh, I see.
Jupiter to the sun is way bigger than 1 AU.
We're looking at the planet in the middle of this ring, not the sun.
Yes, that's right.
Got it. It's one big solar system, or stellar. I guess we call distant ones stellar systems, don't we?
I think they're called exosystems, exoplanet system, exoplanetary.
Stellar.
Ron, in this picture, the planet is here. It's got a moon here, and then the star is here. And Jerry's saying the distance between the planet and its moon is 1 AU, I think, right, Jerry?
Yeah, right. That's in the text. I believe that's what I have there.
Well, gentlemen, do you all understand that? Whittemore and Bruce?
Yes.
Okay.
I just looked up which elements were created in the Big Bang. And well, it looks like 4 of them. Deuterium, helium-3, helium-4, and lithium-7.
Lithium-7.
Yeah, lithium is very light. It's number 3 in the periodic table, I think.
What does the 7 mean? 3 protons and 4 neutrons in the nucleus?
Yeah.
Yes, exactly.
Yeah, right.
And that's a normal lithium.
It's got extra neutrons in the nucleus.
Huh. What's number 4?
Nucleus.
Anybody know what number 4 is?
Well, it has 4. Helium has 2 protons, 2 electrons normally. So helium-3 has 2 protons and 3 neutrons. Helium-4 has 2 protons and 4 neutrons.
Yeah, the 4th element, Ron, is boron.
Boron.
Yes.
Oh, beryllium.
The 5th one's beryllium, right, Tom?
Yeah, other way around, it looks like.
Beryllium, okay.
I think it's beryllium is 4 and boron is 5.
Okay.
The lithium is over there on the extreme left, isn't it?
Yeah.
Right.
Number 3.
Yeah,
3
so I thought,
protons.
okay. Yeah.
So any element on that table has a normal number of protons, to be sure. That's the number, actually. And then a certain number of neutrons. And if there's ever less or more neutrons, it becomes an ion.
No.
Nope.
An ion is missing electrons.
Oh, it is.
Yeah. It's
Okay.
ionized.
Was
What
it
happens if they add-
nucleotide? Nucleotide, is that what it's called? What?
Nuclide.
nuclei.
Huh. Well, I learned, among other things, that neutrons are simply a proton and an electron together. Am I fair in that?
Not exactly right, but it's the way I think of it. There's also what is the neutrino involved.
And Ron, you heard the one about the two hydrogen atoms walking down the street?
I have, but I don't remember the punchline.
One of them says, "Hey, I think I just lost an electron." And the other one says, "Are you sure?" He says, "Yes, I'm positive."
That's astronomer humor.
Yeah.
Only guys like us laugh at that stuff. Or I'm calling me an astronomer. I don't even own a telescope yet. What are we looking at here, Totten?
And these are neutrons and neutron stars.
Oh,
So-
yeah, they're all crammed together, aren't they?
That's a
They
little
talk
off.
about they talk about neutrons being made up of quarks. Like here it says like one up quark and two down quarks, and there's gluons holding it together. That's one way of looking at a neutron.
Uh-huh. But when you lose an electron and become, as Bruce said, an ion, could you lose it into a proton and suddenly you got a new neutron?
No, it's in the electron gas that's around the nucleus.
Gas?
Well,
So
it's
the blurry
historic
ball.
way they picture this, electrons are in an orbit, but they really aren't. They're just a cloud around the in various layers, a cloud
Yeah.
around the nucleus.
Mhm.
Just like the planets and the suns.
If you take a neutron and put it all by itself out in empty space, it's an unstable particle, and its half-life is 15 minutes. And it will decay into a neutron an electron and
A
a
proton.
proton and a neutrino.
Yes.
Does it suddenly make a hydrogen atom?
No,
Doesn't do that. They don't orbit each other. One electron
No.
is smaller. Okay.
And Ron, just another
Yes.
one here. One of my favorite treats when I go camping are fig neutrons.
Do they glow in the dark?
Yeah.
Well, you know what we might want to go to now, gentlemen?
what?
If Tom can, I ask if we could show this. It's kind of controversial, but the forwarded card, it's not a cartoon, it's a genuine official embroidered patch for the, you want to put that up there? He called it,
No. Oh,
I call
no.
it Q, and you don't want to do it?
Oh, that's kind of strange.
It's a
Well, all
little
right.
political.
It is.
Yeah.
But they didn't start the wildfires. That's all I'll say. Okay.
Smokey the Bear started the wildfires.
He probably did. He's ticked off his all get out.
If you save fuel for 100 years, then when you finally have a fire, it gets out of control. You can't
Right.
control it.
Okay, let's
Indians
go.
used to burn the hills like every 5 years.
Jerry, what do you want to do?
Okay, you're right, Bruce, but let's get back to the, let's look at the space rock on your face.
Oh,
The dwarf, because this is a photographic opportunity. That's
it's
quite nice.
one series, largest
Yeah,
rock in the
one
asteroid
series,
belt.
it's going to pass this month. It's going to pass through the Hyades, an open cluster, nice open cluster. So you can set up a small telescope that has a wide field of view, say a 100 millimeter diameter aperture refractor or something, and you can take a picture every night of the Hyades, and you will be forming a movie of Ceres moving through the Hyades. And with that density of stars, and the Hyades is a beautiful cluster, it's going to be very dramatic just watching the Ceres move through there. Probably take 2 pictures a night so it doesn't jump so much, maybe more. So it's a good opportunity for anyone it's an easy photograph to take. Just be sure you take the Batinoff mask off the front of your telescope before you start shooting the picture.
Yeah, and 1647 is this beautiful open cluster.
Yeah,
Very young stars.
How many
you have to
dwarf
have a pretty
planets?
wide field to see that too, but yeah.
So middle of the night, focus on Taurus's bright red eye, Aldebaran, 16
Mhm.
degrees above the horizon by 9 o'clock. And there it is. How
Yeah, it's
many?
an unmistakable star, and it's very pretty.
We only have two dwarf planets in the asteroid belt.
We have two what?
Dwarf planets
Dwarf planets?
in the asteroid belt. Ceres, one of them. Vespa is the other. Or there are three.
I don't know. I don't know the other one. Is there another spherical one?
We just talked about it the other.
No,
couple
no,
Mondays.
Ceres is the only one considered a dwarf planet at this point in the asteroid belt.
Yeah.
Well, what is Vespa? Is that a?
Oh, Vesta. Vesta.
No,
Vesta.
Vespa is an Italian motorcycle.
That's Vesta.
Oh, that's got a P in it.
Yeah.
Yeah, Vesta's, go ahead. Vesta's
That's a
just an
good
asteroid.
question, because it depends on how round is. Vesta is not as round as Ceres.
Mhm.
Okay.
So I don't consider it round, but we'll have to see what definition of things they come up with.
But
I
this-
just searched dwarf planets in the solar system, and they came up with 5 of them: Pluto, Eris, Ceres, Makemake, and Haumea.
Yeah,
Haumea.
Well, some of them may not be in the
those
asteroid.
are out in only Ceres is in the asteroid belt, I think.
Oh, okay.
Really?
Yeah, the other ones are out in the Kuiper belt.
Okay. Yeah, it says in the solar system. Okay.
Yeah,
Have we visited it with a probe?
yeah, we've visited Pluto and Charon and
Well, I don't know those. I'm talking about Ceres.
Ceres. Yes, we visited
Yeah, we got
it, orbited it real close. Remember, I think last week we showed surface features from Ceres.
The Dawn spacecraft in 2015 took
Right.
pictures.
Yeah, very good dramatic pictures. Ceres is believed to have more water on it that's close to the amount of water on Earth. It's largely water. There's a lot of water in space. Future astronauts and spaceships are going to have no trouble finding water to drink, to purify, to drink, and also to make hydrogen oxygen fuel out of. So they don't need Earth.
Is there a number of seeable asteroids that we can spot on a regular basis? How small can they be?
I think virtually all of them you can't see with the naked eye.
Well, I didn't say that, but I'm obviously we're going to look at this with the naked eye or with a
No,
telescope.
no, this is going
Oh,
to
no, telescope, Ron, telescope.
Yeah,
For
and with big
Ceres.
enough all of them have been seen with telescopes. That's how we find them.
Yeah.
Okay.
I think
Uh,
Jerry was recommending a 4-inch refractor or something like that.
Yeah,
Mhm.
And so
Yeah.
it changes, just like all the other planets, Mars and Jupiter and Saturn, it changes position every night. It doesn't go like the stars do.
yeah. Ceres is magnitude 7.7.
It's-
Oh.
So with a 4-inch, 5-inch, 6-inch amateur scope, which are common sizes on the low end, this is easily visible.
Mhm.
What magnitude number is where we can see it, begin seeing?
Real
Something.
dark skies on a mountain or something, and you're not drunk, it will be about magnitude 6, possibly a little over. Here in the city, it's probably magnitude 3 or 4.
Okay.
In southern Utah, 7.
Yeah,
And then it goes down to 0 and even minus.
Mhm.
Well-
Venus is like what, -3 or something like that.
yeah.
Oh, right now, I think it's probably more than -4. It's
Yeah.
really
Okay.
bright, really bright.
It is very bright. Well, so is
Yeah.
Jupiter.
Mm-hmm.
Well, I'm going to imagine that this dwarf planet Ceres, if it's the biggest of the rocks in the asteroid belt, I imagine it probably occults a lot of stars, being as big as it is.
I think that it occults its fair share. Chuck would be the one to talk about it. We can ask him about it next week.
Okay.
Yeah. Yeah.
Nobody knows what he's doing.
Just a little note on Venus. So some years ago, I went to school in Tucson, but we were having an astronomer teaching, conference up in the Santa Catalina Mountains where there's some nice scopes. And during the mid part of the day, the fellow who was running the thing, McCarthy, who basically defined he designed the width pick cameras and stuff that went on the Hubble. he said, anybody want to see Venus in the daytime? I said, sure, sure. And he said, just sight your eye along the telescope here and you'll see it. And there it was. You know?
Mhm.
So if you know where to look, you can see Venus in the daytime.
Oh, even above us.
Yeah, you have to really know, Ron, where to look, though. You know, okay. Okay. And Venus is also a planet that will cast shadows in a good dark place. It'll cast
Really?
shadows. Mm-hmm.
I used to use a trick when I was starting out in high school with a telescope to find Venus in the daytime or any other planet in the daytime. And I'd look at Venus, I'd line my telescope up with it was an equatorial mount with the North Star. And then I'd turn it so it was looking at Venus. And then I'd lock the telescope down and I'd go to bed. And then I'd get up the next day and I'd unlock the telescope and I'd slew it in right ascension back to the region where I knew Venus was going to be past the sun. And then I'd cruise around on that declination and pretty soon I'd find Venus again during the day. But anyway, if you go to the next topic down, which is the planet Uranus and Frederick William Herschel's birthday.
Yep.
You can see in there that the third paragraph says that the planet Uranus is shining at magnitude 5.7, which is just visible to the naked eye under a dark sky. So that, you know, it's a challenge. It probably is not visible from the city here without a telescope or binoculars. But if you're out, way out, like if you're up at Tuolumne Meadows camping or something, and you knew exactly where to look, you could probably see Uranus with your naked eye. So that gives you an idea of how bright these things have to be seen by naked eye.
I was just going to mention another fond memory, thanks to Gail Massey, you know, a longtime member in our club, was, you know, William Herschel was a very good composer. And that's why he had actually went to England and then fell in love with astronomy there. And Gail Massey gave me a recording of several of William Herschel's symphonies. So you have to remember that, you know, he was writing these symphonies in the ballpark of when Mozart was writing symphonies, okay, or when Beethoven was very young. And they're very classical. They sound quite a bit like Haydn, you know, quite a bit like Mozart. He wrote a bunch of symphonies. I had about 6 of them from Gail.
Jerry, according to your notes, Uranus is inside the constellation Aries the Ram.
Mm-hmm.
You look south to find Aries' brightest star, Hamal, and then find Cetus's alpha star. What is Cetus? What is that?
The whale.
Oh, okay.
Whale.
All right. That's not on is it on the ecliptic like Aries?
No, it's not it is on the ecliptic or the planet wouldn't go through it, but it's not in the zodiac.
Oh, okay. But it's on there. Brightest star is in Aries is Hamal.
Yeah, Hamal.
Okay.
Mm-hmm.
Then find Cetus's alpha star Menkar, about 23 degrees southeast. Uranus is halfway in between. There we are.
Mm-hmm.
And you can see it with the naked eye.
In a good dark sky. Yeah.
Did old man Messier ever lock on to Uranus and give it a number, or did he only?
No, you know, well, this was discovered in 1781. Okay, you know, during Mozart's lifetime. So that's well after what you're talking about. Okay.
Okay, but
and then Chuck always would tell the story about how when Galileo was pointing his telescope up at the skies, he may have seen Uranus. Okay. He may have actually seen that darn planet. And this would be, of course, in the early 1600s.
The ring around Uranus seems to go up and down, or at least it's not flat like we're used to seeing on Saturn. That's because it's tipped. It's the planet that's tipped on its side. And that ring is...
Yes.
That's just the aspect it's presenting now. It'll be flatter from our view in the future and has been in the past.
Mm-hmm.
But all rings around planets, and apparently it seems like our 4 gas planets all have rings. Are they all right above their equator?
I think that's correct.
Yeah, they align with the planet's axis of rotation.
That's right. Yeah.
Well, something knocked that sucker on its side in its orbit, and it just stayed there. That's fascinating.
Very, very likely. Yeah. very likely.
Yeah. And those are the moons, Umbriel, Miranda, Ariel, and Titania.
Titania. So
Titanium.
have you ever done this physics experiment in high school physics where you stand on a lazy Susan and you're holding a bicycle wheel and the teacher spins the bicycle wheel up with a little electric motor so it really spins fast?
Yeah.
And then you try and move it, it will resist your motion if you try and move it.
Right.
If you tilt it one way, it'll rotate you. And if you tilt it the other way, it'll rotate you the other way.
Yes.
That's because angular momentum is it takes energy to change the direction of your angular momentum vector. And that's why Uranus, once it's bumped off like that, it's going to continue with that axis always being parallel to where it is.
What is that called? It guides planes, the guidance mechanisms.
Its angular momentum vector is the vector sticks out of the pole.
That's not the word I'm looking for.
I think he's thinking of a gyroscope, Jerry.
Gyroscope.
Oh, a rotation plane? Yeah. Yeah, gyroscope represents the same angular momentum properties.
What would happen to the kid being spun? What would the thing fly out of his hand?
No, as he tips it, it simply makes him rotate.
Well, they use that in a lot of the space.
What's that?
It's used in spacecraft that have telescopes because they don't want to use rocket fuel because it goes out and condenses on the scope.
Right.
So they use
So it gives
reaction
them
wheels.
Reaction wheels. It gives them something to push against.
Yes.
Right.
It doesn't want to move. Saves a lot of fuel.
Fascinating.
I've
stuff,
often
man.
wondered, if they use reaction wheels and they push and they keep needing a little more push, they must be rotating at a fairly,
It's very,
a two-dimensional rotation. You got the wheel rotating, and then around the opposite, the orthogonal axis,
Yeah.
it's also rotating.
they're real dense metal things that look like fat saws.
Looks
Yeah,
like
there's someone playing with the angular momentum, learning angular momentum.
Tom Totten has called it up on screen. Can you believe that? You're awesome, Tom.
Of course, that wheel's not rotating.
Right.
There it is. So she's standing on a lazy Susan.
Well, it makes
Well, you
sense.
could take a same wheel like that and spin it up and then just put your finger on one side and it won't fall over.
That's right.
It'll precess though. It'll
It can't fall
precess.
down.
Right.
Where did you find that, Totten? You're awesome. How in the world was that?
YouTube has everything.
All you gotta do is type it in. I thought maybe it came in Jerry's talking points and I missed it since he brought it up. Yeah, fascinating.
See, she lets go of it with one hand and it doesn't fall.
Gentlemen, we still got the demon star or ultra diffused galaxies to talk about if you want to get into either one of those topics.
Let's look at UDGs.
UD galaxies. Can I read off the qualities? They are very low luminosities, dim and hard to see. They have few stars in them. There's little star formation. They're basically just big gas bags, aren't they? Commonly found in galaxy clusters and a wide range of sizes and shapes. Ultra diffuse galaxies. What can you add to that, Mr. President?
Well, they appear to be galaxies that have somehow interacted to have star formation basically stopped in them. One theory is that supernova from an initial phase of star formation may have puffed them up from dwarf galaxy sizes and inhibited further star formation. So they're considered, under that scheme, they're considered failed galaxies. But it's not well understood. They're still making up hypotheses that fit these observations because they do not appear to be, they're in, the photograph that he's showing is in the Virgo cluster. And it's these types of diffuse galaxies that are highlighted, and the inset shows a close-up of them. These are taken by the Japanese telescope, Subaru, on Hawaii, and one other one, but I don't see the name of it. Anyway.
There's 3 types of galaxies. I can name one. We're in one. It's a spiral, and then there's the ones we're watching now, which are little suckers. What's the third one? There's a third type of
Well,
galaxy.
there's barred spirals, and we're in. There's regular spirals. Then there's irregular galaxies, and then there's spherical galaxies.
Right, and there's ellipticals.
Yes,
Ellipticals. Well, that's what these are.
Lenticulars, sometimes called lenticular.
Seems to me there's, I don't know if you use the word organization, but the ellipticals, they're not organized into something like a spiral, a turning, similar to a hurricane on Earth.
No.
They're just
No.
everywhere.
Back in the 30s, Fritz Zwicky had a scheme for galaxy evolution that he just guessed at from the various shapes. And he put them into a nice tuning fork shaped pattern, which I learned. But apparently it was just made up, and now that's not used anymore.
Right.
Looks like he may have had the tuning fork the wrong way.
Well, these galaxies have a bigger share of dark matter than others, supposedly.
Yes, they're pretty much mostly dark matter. All the light matter has been somehow smashed away or pulled away from a collision, something. Or at least star formation has been turned off in there.
Okay,
So
an
there's not enough dust and gas dense enough to start the gravitational attraction to form new stars.
So we're looking at mostly dust and gas there.
Yes.
Those
That
bright,
is not that.
those bright stars are what, in our galaxy in the foreground here?
Those are actually galaxies that you're seeing through this front galaxy, I think. And so really this is probably a lot of stars here mixed with gas. So it's very diffuse. I mean, the stars are not clustered into a core, I guess. Is that right, Jerry?
Yeah, they're not able to form the traffic jams that of rotation gives the spiral shape or the flattening shape.
Do they have names for them?
I'm not going to claim any expertise on galaxy structure. I'm an avid student of it. So,
But do they know, they estimate how many stars are there? Most
I haven't seen
galaxies,
an estimate of. They're very low count galaxies apparently.
but we're not talking it's got 8 stars or 12 stars. It's still got
No.
hundreds of
And
thousands.
Ron, remember you mentioned those like spherical looking little dots there? Those
Yeah.
are probably foreground stars in our galaxy. That'd be my guess.
That's what I'm thinking too.
Yeah, I think they are foreground stars.
Well,
They
I don't see
belong
any,
with this diffuse thing.
Tom, I don't see any diffraction lines on them though. So that I can see that's a galaxy, that's a galaxy.
Oh, yeah, no,
Can't
those are,
tell.
Tom, those are definitely galaxies. I'm just talking
Yeah.
about the little dots, some of the dots.
Yeah, the
Yeah,
round
some of
dots.
them.
Yeah.
In the spherical
looking at-
structure in the middle. These diffuse galaxies can have up to 100 billion solar masses in them,
Wow.
But they're
but
not
it's not
stars.
all visible matter.
Wow, just solar masses.
If you
So that is-
expand the center of this thing, it looks like a whole lot of colored confetti in there. Well, what you know, I mean, those are the stars. They're various colors.
Wow.
Well, Ron, our galaxy, the Milky Way, they say that our galaxy is 80% dark matter. So
Yeah. So this is even more so, but I don't know how many of you gentlemen are experts on Big Bang theory, but at the beginning, it was pretty much gas and dust everywhere, and it just started coalescing in lumps, and that became.
That was way after the Big Bang.
Yeah.
The spectra that reveal, through the Doppler effect, they reveal the rotational speed of these diffuse galaxies. And from that, they infer that they may be composed of as much as 95% dark matter. So that 100 billion solar masses is not 100 billion stars.
Okay. But do you suppose there's any exoplanets in there?
Boy, I don't know. I think if stars form, their planets form too.
And Exo Moons? What do they call a moon that goes around a moon? Or is there such a thing?
Non-existent.
They don't, that's as far as it goes. A moon orbits a planet and a moon orbits a sun, and that's it.
Well, the Apollo 11 capsule orbited the moon for a while.
That's
Yeah.
true. I think there's stuff up there now that orbits it. We got about 5 minutes, gentlemen. There is a demon star we could talk about if we've exhausted this. If not, fascinating stuff. You want to talk about Perseus, lurks in Perseus, a hero? It's Algol, right? Is that pronounced right?
Yeah. Didn't I make some comment about Fritz Zwicky?
About what?
Yeah, that was actually Hubble who said that, Jerry.
Who said what?
Oh, the tuning fork. I think Hubble,
Okay, that's
Yeah.
fine.
Edwin Hubble, who came up with the tuning fork, but as you said, it's no longer believed to be an evolutionary path.
Yeah.
Mhm.
Well, you lost me totally on that, gentlemen. You know, this is interesting. We got just enough time to cover all 8 topics.
Oh yeah, no. Here we go. Look at Zwicky's asterism.
Okay.
Oh, that one. Yeah, I forgot about Fritz.
Yeah, this one I
Okay.
put up there to tease the Baron. The Fritz Zwicky was a guy, an impressive astrophysicist at Caltech in the 30s and 40s and 50s. He was the first person to use the Virial theorem to infer the existence of unseen dark matter, describing it as Dunkelmatter materia. Anyway, but this thing is named after him. It's a ring of galaxies. It's an asterism, but it's not an asterism of stars. It's an asterism of galaxies, 10 to 12 galaxies beyond 18th magnitude. So you will not see these even in a small astronomical telescope. Most of our telescopes stop at 13 to 15 magnitude. This is at 18, so you're going to need a long exposure to get it. It's approximately 1.8 billion light years from Earth, but it's just a pretty pattern. So it's an asterism, but it's a sort of a galaxism.
Galaxism.
Because it's a pattern, an easily recognized visual feature, but it's not made of stars, it's made of galaxies. So just because it's a pattern, it's like an asterism.
Is that in the upper right of that photograph we're looking at?
Yeah,
Right?
yeah. Tom had his cursor on it for a while there. There.
Oh, I missed that. That's Zwicky's necklace.
Yeah.
Wow.
Yeah, he was not a very nice person.
That's the rumor. I never met the guy.
Yeah.
I know
He was
one
a
of the-
Serbian.
What's
He
that?
hated
He's a
he hated
Serbian.
Walter Bada.
Yeah.
He really hated Walter Bada.
Even though they collaborated at first on many interesting papers,
Yeah.
but he one time called someone a spherical bastard because he said no matter what angle you looked at him from, he was still a bastard.
So those are not those strange ultra diffuse galaxies necessarily. They're regular spinning spirals, I guess. But
They haven't been. I haven't seen a classification of what kind they are,
Mhm.
but it's definitely a distinct feature.
well, your note said 10 to 12. They don't know exactly how many are in that ring.
But like most things, if you look at something and you see like the Pleiades, you see 7 stars with your naked eye. But if you take a picture and you catch more light from fainter stars, then the number grows to be much bigger. So it depends where you stop collecting light, how many stars you see.
I took over the job of vice president from a young man named Adrian, who might be sitting in Zwicky's chair down there at Caltech right now.
There he is.
Is that him?
That's
That's
Well, if Adrian comes home, we're going to ask him. Virial theorem. I have no idea what that is.
I'll explain it for you. Explain it to you next time.
It has something to do with, he was at the beginning of the dark matter theories, right? He came up with,
No, he just noticed that it was sort of in the background and nobody understood what was going on until it became an official popular topic in 80s or 90s.
did dark energy come later, or was that part and parcel of the same dark
That
matter?
came later.
It did.
Mhm.
Fritz Zwicky, asterism.
This is an interesting but not quick topic, the Virial theorem.
yeah, right.
Wow. Interesting stuff. Fascinating. We got through everything pretty much. Didn't do a lot on the Demon Star, but gentlemen, I assume you're going to be enjoying Thanksgiving in a week and a half. And I guess we'll be watching the launch of the Dare from our Space Force.
Dart.
Yeah, Dart.
Dart, yeah. And I guess we've run out of time. We're getting down to the wire. Anything going on, Bruce, with your Theater Organ Society? Any concerts planned?
Well, I mean, because of COVID and when the theater was dark and vacant, we spent over 650 hours doing maintenance. But
Oh, okay.
no, in terms of public getting in there, no.
Yep. You're just waiting for the pandemic to get over like the rest of us. And
Well,
bird
if you go
watchers-
look at the CDC website, they have a lot of plots. The infection rate hasn't gone down. It's just that people are kind of trying to ignore it.
well,
I mean, it went way up in January, came back
Yeah.
down again. Then the Delta variant came in and it's come right back up to, like 65, 70% of what it was in January.
yeah, we got the
and-
winter surge coming on.
Yeah.
Yeah.
No problem. Good.
Yeah.
But I assume you've all got your third shot and your flu shot, and we will convene again next Monday morning, this same time.
Ron, one last thing I wanted to mention that for the telescope workshop on Tuesday nights, we have a member, his name is Dick Beam, and he wrote this little paper explaining his astrophotography of the Vale Nebula. And really nice. It's like 9 pages, and he goes into detail on what's there into the nebula, and somewhere located in part of the Milky Way, bunch of gas blobs, and he kind of details what he was seeing there in his great photography, wide field photography. And then he gets these great little nebulas that he discusses. So
I have
just
lost
want to
my-
mention a telescope workshop Tuesday nights at 7:30.
Yeah,
Okay,
tomorrow
okay.
night.
All right, that's tomorrow. And take care of yourselves and give our love to your wives. And we'll talk again next Monday. Fair enough?
Yep.
Right. Thank you, Ron.
Sounds